Ocean assets are valued at $24 trillion, providing essential products and services to billions of people and home to millions of species. Plastic pollution, climate change, illegal, unreported, and undocumented fishing, human-wildlife interactions, and many other threats significantly erode this value. On the other hand, there is ample opportunity to celebrate. Billions have been spent on conservation. Species have come back from the brink of extinction, fisheries have improved, tourism has value, and protected areas have grown. Everything we know about the world's oceans and its influence on society depends on the important discoveries made by marine scientists. The problem is that science is manual, siloed, and slow, lagging years to decades behind business, society, and ocean change. Some are speeding things up and making science more collaborative through crowdsourcing, citizen science, and co-generated science, often using phone hotlines, emails, or species or location-specific mobile apps to collect data from ocean explorers. For example, people love manta rays. Tourists spend more than $140 million a year in just 10 communities to see them. So alarms rang when they started to disappear, and I was solicited to help. By crowdsourcing observations from ocean explorers around the world, we revealed that although only 2 countries reported catching manta rays, that they were being caught and sold in markets around the world. And this discrepancy was enough to help them get onto the endangered species list. But even this was still manual, 1 observation at a time, 500,000 records, and we can really only use the data for that one purpose because of ethics. You have to get permission to use them for all the purposes that you want to use them for. I estimate that about $5.7 billion a year of research dollars is wasted in these manual processes. And this doesn't account for the costs associated with mismanagement, misdiscoveries, miscommunication, or delayed action. So this is a problem that I really wanted to fix. How is your MPA, ocean, coastline, endangered species, invasive species, intervention, blue economy, blue carbon, etc. doing today? Not 5 years from now or 10 years from now, but how is it doing today? And this is where eOceans platform comes in. It is a platform to automate all the tedious and time-consuming aspects of ocean science, so you can focus on designing your survey and collecting your data and interpreting results for action and decisions, and all the stuff in between can happen automatically. It helps to maximize your budgets and your time as well as your impact. So how does it work? Everything inside of eOceans is determined by teams. So a team can be a public team or a private team. Public teams, all the data stay inside of the platform, and a private team, that's for when you have trust between the contributors and all the participants so that you can download the data and use them outside of the platform. Otherwise, you can have a public team and everyone that's contributing can see exactly how their data are being used. So to get things started, you go into the dashboard and you create a team. You have a project name, your logo, and across the bottom here, you'll see tabs to all the different parts of your dashboard. Location is really important because all the teams inside of eOceans depend on location. That is the first thing. What is your study area? You input a shapefile or use one of our shapefiles to determine and delineate the area that you're interested in. And here I've shown a hypothetical marine protected area inside Polygon and a buffer around. So if you wanted to compare inside to outside, say fishing the line, or what the activities, how the different activities compare between different zones, for example. Next on your tabs, you've got observations. So these are all the observations that are being contributed to your team. So you can do some high-level QA/QC, for example. Overview, that's where you as the team admin, you describe what your project is about. Same with description, that's more detail. Management, if it's a marine protected area or an area that has restricted activities, that's where you would put it to communicate that so people know what activities are and are not allowed in that area. Results, I'll give you some insights onto what the results look like, but this is where all your data associated with your team are being analyzed and visualized in real time. The discussion tab is where the admin can discuss the results that they're seeing. The comment tab, that's really the co-interpretation channel where the admin can get feedback from the users and the contributors and the other team members on how to interpret the results. The users tab, that's where you can manage who's part of your team and who is admin inside of your team. Metrics is really around its results of your team. So it's different than results of your project, but it's who's involved in your team. For example, if you have a marine protected area that's visited by people all over the world and they're all contributing to it, you can really see the impact that your team has globally. And reports, that's where if you want to generate a report, a PDF report of your data, then you can do that there. Or if you have a private team, you can download your data there. So the mobile app is one of the primary places where we gather data. And this can be used by your scientists, your citizen scientists, or tourists, or the public, or your fisheries group, whoever it is that is part of your team. And they can use this primarily as an activity tracker. So you press start and stop and you track your activity, whether you're sailing or fishing or surfing or kayaking, and you track your activity and you log your observations along the way. And the observations can be of any species or of any humans. And humans can be, somebody surfing or sailing, but it could also be of plastic or ghost gear along the way. Other ways to get data into your team are we've integrated with OBIS and ERDAP, which enables historical data to be incorporated and different types of data to be incorporated, but also allows for physical chemical data because the mobile app collects biological, social, anthropogenic data, but we want to be able to couple that with physical chemical data. So we can do that so we can understand like the impacts of climate change on species distribution. So this is a good way to get more data associated with your team. Another feature that we have is a notification system. And this is for teams that have really time-sensitive things that need to be communicated. So for example, North Atlantic right whales in my area, orcas and other places around the world, just the sighting of those animals needs to be alerted so that, for example, you could slow down ships. So the way the notification system works is that the admin gets an alert, which comes through SMS text, and they get an alert that something has been observed. They can validate it and then send out a larger SMS text and in-app notification to other users nearby to slow down ships, for example. Another cool way to use the notification system is through interactions. So if somebody sees a whale and another person reports ghost gear and they're close by, then you could get a notification to say, hey, let's go and remove that ghost gear because it is a near miss. But really the notification system can be used for a wide variety of things like underwater munitions or fish kills or whale strandings, so many different things. So as the data come in, we're always analyzing it and displaying it back to you, the admin, as well as to your team members. So here is just an example of one of the analytics that we provide, which is your MPA health score, which tracks the abundance or diversity of the target species inside of your marine protected area, as well as the social benefits and engagement within your MPA, all the while counting for the negative impacts of overuse, garbage, pollution, and other ways, so that everyone can know how their MPA is doing today. Here's another view into the summary analytics. This is where you would just see high-level analytics around the activities, the species, and the observations that are being made. And I included some bubbles below of how people can be co-interpreting the results. And then when you download your reports, it looks something like this. There's a report and you have all your analytics in it. And if you want to get the most out of your team, you can upgrade to have advanced or custom analytics. Here I'm showing biological, social, and anthropogenic analytics. And these are interactive graphs where you can slice and dice however you are interested. At eOceans, we're in support of fair data practices that's findable, accessible, interoperable, and reproducible, but the user decides. So we make it easy to standardize and provide clean data, but it's a platform where all of the users own their data and they decide who they're sharing it with. And this supports self-declaration, data sovereignty, inclusivity, as well as protecting special places and species. And this is also important for the ethics of publication. So some of the studies that I used crowdsourced data. I could only use it for that purpose because I didn't go and explicitly ask to use it for different purposes. So this will help proliferate the usability of data across spatial and temporal scales. And the platform, although it's very good at monitoring biological aspects of ecosystems, including endangered, invasive, commercial species, and socioeconomic values, including what activities are where and when, how that changes by week, by month, by year, as well as anthropogenic, including plastic pollution, ghost gear, noise pollution proxies, and nutrient pollution proxies. But it also can evaluate interventions. So because it's multivariate and interactive, we can look at the impact of protected areas, education, fisheries gears. So when we change gears, what are the implications of that? And wastewater treatment. For example, where I live, we started to treat our sewage instead of dumping it straight into the ocean. And before, people were too afraid to go into the ocean. But now you see kayakers, stand-up paddleboarders, jet skiers, and fishers. Many people are using the ocean. And that has socioeconomic value. So we would like to be able to track, when we're making investments to clean up the ocean, what is the reciprocating value that's being gained? And in summary, I would like to remind everyone that ocean spaces are complex and dynamic. They vary by area. Every study varies by location, area, habitat, distance from shore, the human uses that are nearby, the ecosystem types, the goals and the objectives of the project, and how humans, value the ocean and the species that they're interacting with, as well as proximity to ocean currents and noise and so many different things. So if we can gather and couple all these different data types together, including biological, physical, chemical, social, anthropogenic, and look at the interactions in real time through varying spatial and temporal scales, then we can get a better insight into how the ocean is changing, and then we can make informed decisions and actions for the future. I'm Christine Wardpage. I'm the founder, CEO, and lead scientist at eOceans, and I'm excited to be able to share this platform with you and to be able to collaborate with you on different projects that are already existing inside the platform and future projects, and to learn new ways that the platform can help you to track your ocean spaces in near real time, collaboratively and transparently. Thank you.